So my talk is about how to make dev and ops folks look good as an SRE. I think not everybody here is an actual SRE because that was asked yesterday during some of the talks, and there was only a few hands going up, but still, I think it's going to be cool for everybody. So what is the problem? I think what a lot of people are seeing is that they are struggling to get the right amount of performance, the right amount of resources for their applications once they are migrating to cloud native solutions, right? So Kubernetes most often. And what we see is that people tend to over provision quite a bit. And that is an issue obviously from a cost perspective. If you do want to optimize your settings for Kubernetes or applications running in Kubernetes, that's actually a really hard task, and it will take a lot of effort to do so. Now, obviously, also the usage of an application is not going to be static, so it can change over time. It will continuously change, basically. So if you want to maintain the right settings for your application, it's going to be a pretty heavy task. One of the other issues is that if you have an application that consists of many microservices, you have to maintain the right settings for all of them. So as an example, if you have an application that consists of 20 microservices, how are you going to manually tune all of them? And what happens if you tune one of them and it negatively impacts the performance of your application? You have to revert that and you have to try other settings. And then obviously you get lots and lots of variables, which is basically undoable for a human to get the right settings. Which is disappointing, obviously, because everybody's moving to microservices, to the cloud native, and there's a lot of promise with it, right? So like it says here, faster time to market, superior user experience. Well, we all wish that was true, but it's not that easy. The other thing is scalability and reliability needs to be up to par, obviously. And also, how do you maintain that? So the issue that we are seeing, that we have a lot of discussions about, is complexity, because obviously Kubernetes is not simple. It's all over the news. It's all over the websites that we read. It is fairly complex, especially since you have so many moving parts. You have many abstraction layers. That doesn't really make it that more simple. The other thing is that what we've started doing is collecting metrics, right? So we have all these moving parts, and we want to collect all the data about all of them. So you end up with huge amounts of metrics, and if you're lucky, you get some really nice visuals. You get some graphs and how things are. But what do you do with this information? So if you, for instance, have an application that is lacking in performance, maybe latency is high, throughput is low, whatever it is, how do you take action? So how do you convert these insights that you're getting, this information that you're getting, how do you convert it into action, basically? So the skills gap there's multiple facets to the skills gap, right? Kubernetes itself is fairly complex for a lot of people. Some of our prospects that we talk to have been on the Kubernetes journey for years. Others are just starting out. They're moving from potentially physical infrastructure still, from virtual machines to Kubernetes. So there's a lot of things to learn. And then again, all the moving parts that we're discussing, that adds a lot to the complexity, obviously. Now, Canonical did a research last year. I think they did a new version this year. And they asked, what is the top priority in your environment? What is it, what you're looking at? No surprise, security was priority number 1. But the next 3 were all about resource optimization. Because what we're seeing is it's fairly easy to deploy an application once you've written it. But if you're over-provisioning all the resources, the cost is going to be really, really high. Now, why is this such a problem? When the developers create their application, usually they are responsible for setting up the requests and limits in Kubernetes as well, right? So just to make sure that the application runs well, they will give it sufficient resources. Then they run it, and the application is okay, but somebody starts complaining about the cost, so the cost needs to be reduced. But who's going to make that decision? Who's going to say, oh, let's reduce the resources for this specific pod in your application? Operations, maybe, if they're brave, they're going to say, let's reduce the resources, but what happens if it negatively impacts the performance of their application? Who's responsible? So this is, it's definitely high on the agenda of organizations to reduce cost, obviously, but it is fairly complex to do so. Again, if you have many applications that make up your application, containers that make up your application, and then you also have your application settings. So for instance, if you're running a Java applications, you also need to take in consideration your heap sizes, garbage collection settings, and all these kind of things. That makes it even more complex. CPU and memory limits and requests, it's just really hard, basically. So what tends to happen? People tend to over-provision. So you have to make either of these three choices, right? You either over-provision or you risk poor performance and reliability, or you're just wasting a lot of time, you're spending a lot of time on manually tuning. Now the over-provisioning is going to result in cost, which is, in our experience, is the choice that is made most often. So people tend to just over-provision because the application will keep running, hopefully, and cost, yeah, well, that's maybe not my issue. But yeah, there's more and more focus on cost, so that needs to change. The alternative, again, is to put a lot of time and effort in tuning the application, reducing the resources that get allocated. Because for those who don't know, I didn't mention it yet, but if you set a request on your pod, that's what's going to be allocated, right? Even if you don't use it. So let's say you're allocating 2 CPUs for every pod, and you're only using maybe a quarter of it, you're still paying for the rest as well. And also, if you're doing this in public cloud, obviously there's going to be a bill associated with that. But if you do it on-prem and also in the public cloud, what you request is going to be reserved, like I said. So that means that if you have 2 CPUs in a node and you claim 1 CPU per pod, you can only run 2 pods. Even though maybe only a quarter of it is actually used. So you're going to be very underutilized in your, on your nodes. So that's manually tuning that is something that a lot of people do. I actually talked to some of you today who said, we have a team of people looking at this and trying to reduce those resources just to save money. But it is such, it just takes so much effort and it takes a lot of time. So potentially that's not worth it. So they just keep over-provisioning. What we see a lot today is that people run Kubernetes, they have their applications, they have some sort of observability platform, so they're collecting all the metrics. And then they, like I said, they have people looking at it, trying to make good changes, propose good changes that then get put in a manifest file. They get put in production, and then you have to look at the graphs again. Did this create the effect that we wanted? Is the performance still good? And is the cost lower? Are things changing? Is there any issues with it? So like I said, a lot of manual labor goes into this. So obviously I represent StormForge. What we did is we created something to automate this. Again, you still have obviously your applications running in Kubernetes, you have your observability platform, but what we do, instead of just creating a nice graph, we actually take the metrics that are relevant for this sizing exercise, we put it through machine learning, and we have machine learning decide what would be the optimal setting. And obviously some of the metrics that we get are actual usage of resources. So we get what has been requested, what the limit is, but also what the actual usage is. We take historic data as well. We feed that to the machine learning. And historic data is about 2 weeks back. So if there's a pattern in your usage, we will take that in consideration. Then a recommendation comes out, and you can either manually or automatically approve those. We then patch the actual deployment. The application gets restarted, obviously depending on how you have set this up. And then we basically have this continuous circle of optimization that goes on. Now, when you set this up, you can also define risk tolerance. So we can set a high risk, medium risk, and a low risk. Low risk means that we give it some headroom. So if you do a high risk, for instance, what will happen is the actual request, the request setting that the machine learning will recommend, will be very snug, very close to the actual usage line. So obviously your savings are going to be optimal, but if there's a all of a sudden a peak that we couldn't predict, you will potentially still run out of the request setting. So if you want to go medium or low risk, there will be a bit more headroom there. It just depends on the goal that you have. The deployment, so the recommended change can be deployed automatically, but you can also have it exported to a YAML file, for instance, and then check it into your Git solution and have it deployed that way. Another usage of our platform is to prepare for very specific scenarios. Let's say you're running an e-commerce platform. You know on certain weekends there's going to be really high traffic, while the rest of the year maybe it's a lot less. What you can then do is generate a load test, and that load test is going to simulate that usage. So it's not, on and off. It's not like you have 100,000 users all of a sudden all the time. But you can actually do it in phases. You can say in the morning, usage will ramp up. This is the amount of users that we're expecting, and that number will accumulate over time, and then it drops a little. So you can have a very specific load test that you run against your application. Now, what I didn't mention is that the previous solution is in a live production, so it's obviously running in a production environment. Can also be in a dev or test environment, because there tend to be a lot of copies of your application running that are not actually used. So then it is definitely a waste if you have lots of resources allocated to it. And this solution is more aimed at non-production environments, so test environments. So what we do here is we have a load test generate traffic against your application. Again, we take the metrics out of it, so we look at the performance of the application and feed that back to the machine learning as well. Then what machine learning will do, based on the settings that you give it, it will do different trials. And what that means is experiments, basically. So you say the configuration for specific pods needs to be between, let's say, a quarter of a CPU core up to maybe, I don't know, like 4 cores or 8 cores. That's the bandwidth that you give the machine learning to experiment with, and we do the same for memory. So for instance, you give it 256 megabytes of memory up to, I don't know, 16 gigs of memory. And then what the machine learning will do is it will define different trials, different experiments, and run those against the application. So what it will do is it will change the settings, run the load test, look at the metrics, and do that over and over again. But the cool thing is that it is a what we call rapid experimentation process. So it can really quickly interpret the metrics that it is getting out of the observability platform, and then adjust the settings based on that. So it will really quickly hone in on the right settings for the application based on what you're trying to achieve. Because some companies are looking to reduce the latency, others want to improve the bandwidth, and it's also going to differ per application, obviously. At the end of the ride, you will get a configuration file again that you can then deploy in production environment. So this is happening in a non-production environment. Obviously, it's not, the machine learning will decide that there is going to be a couple of optimal outcomes of these experiments. So it still requires some intelligence to say this is the one that fits our need best, and then you can deploy that potentially. The other cool thing about this tool is that you can, every time a new version of your code comes out and you want to deploy it, you run a test against it just to see if the performance is still the same or maybe less or even better than previous releases. So you know that the performance is going to be okay. Because sometimes something dramatically changes in the code and can negatively influence the performance. Yeah, so like I said, this is a solution that we built. We call it StormForge Optimize. It has 2 modules, Pro and Live. Live is the one that runs in production and non-production, and then Pro is the one that runs in test environments. The cool thing about the Pro one is that it can also take, again, in consideration application settings, right? So if you have a Java application, .NET, or any other framework that you want to use or programming language, as long as the parameters can be exposed through environment variables or configuration files, we can also feed those to the machine learning, and machine learning can do different trials with those as well. What I mentioned with Optimize Live, in the graph here, I was not brave enough to do a live demo like the previous speaker, but And it's going to be hard to read anyway because the lines are pretty thin. But the line here, the yellow one, represents actual usage of a pod. And then the blue line is the recommended request setting. And then the red line is the limit line. So as you can see, it actually follows the actual usage line quite nicely. And if you compare that to what would be normal, is that you have a static setting, and usually that is over-provisioned quite a bit. So the green line would be a static baseline, as we call it, request, and then the orange one would be the limit. Now, like I said, if you configure it to require these amount of settings, that's going to be permanent, right? So as long as the application keeps running, it will allocate those settings, and you're paying for that as well. So that's obviously the savings are. Now the cool thing is, for a platform like this, it doesn't matter if it's 10 pods, if it's 1,000 pods, or 100,000 pods. It will just keep doing this, and it will just keep giving you the best recommendations. For Pro, it has a bit of a different UI. So all the dots in this graph represent the different trials that the machine learning ran. And what you can see from that, well, it's going to be really hard to see, I know, but the lower ones here are light orange. Those are what we call the optimized, the most optimal results. There's a darker orange one here that is the recommended one, so it has the best of both worlds. Because in this case, we were looking at, I think this is latency and this is cost. So to get the lowest latency for the lowest cost. And then there's a blue one. And that is the baseline. So that is the settings that the application would normally be deployed with. And then you can just choose which one you see as the best. Normally, when we run optimize against an application, we do a lot of POCs, obviously, and proof of value setups. We see quite a dramatic reduction in resource usage or need. That's usually somewhere between 30 and 50-60% that we can actually reduce the resources while maintaining equal performance and quite often actually way better performance. The cool thing about machine learning is also it doesn't have bias, right? So when I first set up my first experiment, I thought, okay, this application, I've seen it a couple of times. I'm gonna kind of think, it needs at least 512 megabytes of memory. It's going to need at least one CPU. That was basically my setting. That's what I would go with. And then I talked to some of my colleagues and they said, why don't you just give it 64 megabytes of memory? And why don't you give it like 1/10 of a CPU to start with? And then give it like a top setting as well. And it turned out the application was actually quite CPU bound. So it was relying on CPU for performance, but it didn't actually need all that much memory. So it could go really, really low. What we do with why we have two platforms or why we have two modules to the platform is that normally we run live against most of the pods of a customer's environment, just to make sure that they always have sufficient resources. And then we use Pro for very specific applications. So, for instance, if you're an e-commerce platform, that's going to be an application that is really crucial for your business to run. We will do a very specific load test for that. Make sure that if the scenario is coming around, if, for instance, a Black Friday comes around, again, Black Friday, I've mentioned it quite often the past 2 days. But if that comes around and you want to be prepared for very high load, very heavy load of your application, you can make sure that you have a scenario ready that you can deploy. You know that the performance will be still good. No surprises there. I mentioned observability platforms where we get the metrics from. Today we support Prometheus and Datadog for Optimize Live, so that's the one that continuously runs. And then we can support lots of others for Optimize Pro as well. So it is necessary to have either of those installed for Optimize Live. Performance testing, we have our own performance testing in the platform, but you can also use different solutions. Like I mentioned, we can continuously optimize the pods. We can do very specific load tests, but we can also be part of the pipeline by testing new code, new versions of the code to make sure that they still perform well. or if something else has changed. With the two modules together, we kind of, we see that as a holistic solution. We want to be able to take the data that you're already collecting. We want to take the metrics that you're already collecting and actually add value to that, but also turn them into actionable data, right? So that not just do you have pretty graphs to look at, but you can actually do something with the information that you're collecting and do that in an automated way. Now, the other thing, obviously, the reason why we use machine learning is it can do it really fast. It can do lots and lots of experiments in a relatively short time, but it can also do it at scale. We tend to talk to a lot of larger enterprises, and they, like I said, they have thousands, tens of thousands, potentially hundreds of thousands of pods. Not something that you want to manually tune. At least not something I would like to manually tune. The platform that we support is Kubernetes, but it can be basically any flavor. Anything that is based on Kubernetes, we can work with. And the application optimization is not only for Java, but can be many other solutions as well. I wanted to keep it really short since it is late on Friday afternoon. One thing, just to remind you, we still have a nice large box of Lego over there. The R2-D2 is gone, unfortunately, but if you leave your name and email address, you can participate in the raffle. There's also a nice video game over here. Another great box of Lego. There's a Sonos speaker over there. So make sure you talk to everybody, and good luck with that, and thanks for your time.